So in this exercise, we're given a simple resistive network, and we're asked to do a little bit of detective work here using our knowledge of current analysis to find some unknown values. So what we're given here is three resistors. So we got R1, which is 16 ohms, R2, which is 5 ohms, and R3, which is 20 ohms, configured as we see here. And then we're also given that the power dissipated in the first resistor is 9 watts. So using that information, they're asking us to come back and calculate what the current is. So that's I1, I2, and I3 respectively for R1, R2, R3. And then once we have that, they're asking us to find what the magnitude of the voltage source is. So we should have enough information to do that. Let's take a look to see how this would be done. So the first thing we want to do is make use of this power here and this resistance, so R1 and P1. There should be enough information there for us to calculate I1. So to do that, we need to recall our power equation, which is P is equal to the voltage times the current. But now we're wanting to recall Ohm's law, V equals IR, and we can substitute in for the voltage since we don't know that. So that being the case, now our new equation is P equals, we have IR, which we replace for the voltage, times I. So if we work that out, that's just I squared R. But we want to solve this equation for the current, right? So when we do that, we divide both sides times R and take the square root. So in this case, I1, so what we're looking for, will be P1 over R1 square root. So if we plug those values in, we'll have 9 watts over 16 ohms. Take the square root. If we plug that into the calculator, we'll get 0.75 amps, or 750 milliamps. All right, so there's I1. We've calculated that. So now we're going to need to come up with a equivalent resistance for R2 and R3, because we want to utilize our knowledge of a current divider. And so to do that, we see that that's just two resistors in parallel. So we'll call the equivalent resistance R23, because that's for R2 and R3. What could we replace those two with? And so that's just R2 in parallel with R3. And so we recall that when we have two resistors in parallel, that'll just be R2 plus R3 over R2 times R3. And so in this case, it'll be 5 plus 20 over, got that backwards. Write this correctly. That's going to be R2 times R3 over R2 plus R3 there. And so now it's going to be 5 times 20 over 5 plus 20. And so when we calculate that out, we're going to get 100 over 25, and so that would be 4 ohms. Okay, so that's not really something they asked for, but it's something we're going to need to solve the rest of this problem. So we can use it now by saying that we can use a current divider. So a current divider relationship, so I2, which is this guy here, that's going to be equal to the total current, IT, times R23, which is that equivalent resistance, over R2. So in this case, that IT is the same thing we saw before, It's the same thing as I1. So that'll be I1 times R23 over R2. So when we plug these values in, that'll be 750 milliamps times 4 ohms over 5 ohms. And so when we calculate that out, we should get 600 milliamps. So there's the value for I2. Likewise, I3 is going to be I total, or I1, times R23 over R3. And so in this case, again, it's going to be I1 times R23 over R3. And again, that's 750 milliamps times 4 over 20. And so in this case, it'll be 150 milliamps if we plug that into the calculator. And so we see that when we add these two together, 600 plus 150, we get 750 milliamps. And so this agrees with our total current coming in. So that's a good check there. Okay, so finally, we want to calculate what this voltage is. So we need to recall now that we have R1, which is here, and we said we could replace those two resistors with a single resistor, which we called R23, and that's coming back to our voltage source, V. And so using that, we can come up with an R total. So to do that, we'll call this the green part here. So to do that, R total is just, they're in series, is just R1 plus R23. And so in this case, that'll be 16 plus 4 gives us 20 ohms. So now we know what RT is. We know what the total current is, because again, it's the same as I1 up here. So now we should be able just to do Ohm's law simply, say V total is equal to I total times R total. So that'll give us 750 milliamps times 20 ohms. And when we multiply that out, put that in the calculator, we should get 15 volts. So that's the value of the source voltage. So there, we've solved for everything. We have all the currents. We have I1, we have I2, we have I3, and then when they ask us to solve for the voltage, which we have here.